Hi guys, this is Dr. Manjunath Chennapgod from Anveshana Academy, Bangalore, India. Dear students, in the previous class we discussed about what is thermodynamic property, what are the different types of properties are there, the two intensive property and extensive property we have studied, what are the examples for intensive and extensive properties in detail we have discussed in the previous classes. Okay, and also we discussed what is thermodynamic state, what is change of thermodynamic state. That also we have discussed with taking some live examples. Okay, so dear students, in today's class we are going to discuss thermodynamic path. This is also one of the important topic in thermodynamics. Okay, what is the thermodynamic path? In detail we are going to study today. Okay, so now first what I will do, dear students, I will try to define thermodynamic path. So series of state through which a system passes during a process is known to be thermodynamic path. I repeat, series of states through which a system passes during a process, that is known to be thermodynamic path. Dear students, to understand the definition of thermodynamic path, I will try to take some live examples. I will try to give some live examples, then I will come to the definition of thermodynamic path with the technical examples. What are that? What are those? You can see here now. Okay, so now dear students, you can take on live examples. Then you can see here now the bus is moving from point A to point B. You can name it as a place. I will take my reference. Hubli is one place and Bangalore is another place, dear students. Now, so okay, to understand thermodynamic path, I am taking some live examples. Okay, fine. The bus is moving from Hubli to Bangalore. That is a one process you can call. Moving from point A to B is a process, or moving from Hubli to Bangalore is a one process now. Okay, fine. Now that you can assume that you can take bus as an system. Okay, so now when bus is moving from Hubli to Bangalore, it is going to cross, or it is going to pass the series of places. What is the series of places? That series of places we can tell in thermodynamic states. Okay, when the bus is at Hubli, you can take, the bus is moving from Hubli to Bangalore or point A to B. When it is at Hubli, right, that I can call it as a state 1. Okay, when it will reaches the Davangere, you can take it as a Davangere, that you can call it as a state 2. Okay, then it will reach the Tumkur, you can call it as a state 3. Okay, finally it is going to reach the Bangalore, that we can call it as a state 4 now. Now when the bus moving from Hubli to Bangalore, it is going to passes series of state or series of places, that is state 1, state 2, state 3 and state 4. When you are going to join these all lines, right, you are going to get a curve or a trace. That curve or a trace is nothing but what? Path. If you are taking bus as a system, then that path we can call it as a thermodynamic path. When system passes series of states during a process, that path we can call it as a thermodynamic path. Okay, what is thermodynamic path here now? Series of states through which a system passes during a process, that is known to be thermodynamic path, dear students. Okay, fine. Now whenever I am telling, right, state 1 and state 2, state 3, in between you are getting some states or some places. That states we can call it as a intermittent transition states. That states we can call it as a intermittent transition state, dear students. Now state 1, okay, this is initial state we can call. Okay, initial state, starting point of bus, that is Hubli you can take, and final state we can take, it is final state, and that we can call it as a Bengaluru. These are the initial and final. But whatever the states you are getting in between, right, that state we can call it as a intermittent transition state, through which what actually happening now, the bus is reaching from one point to another point, or system is reaching from one point to another point. Then whenever you are going to join that all the states, right, you are going to get a curve or a trace. That trace or a curve we can call it as a thermodynamic path, dear students. Now these are some live examples I have taken and I will explain you. I will take now technical examples and I will try to teach you what is thermodynamic path. Okay, fine. Now you can take, dear students, now I will take in a delivery truck. Assume that it is the initial point. That delivery truck has to move from point 1 to point 2. You can take again Hubli to Bangalore or A to B. That delivery truck may go in this fashion, or the delivery truck may go in this fashion. Assume that, dear students, it is going in this direction. Assume that it is going in this direction and it is going to cross or it is going to pass series of states or series of places. Then it will come one, you can take it as initial 1, intermediate I will mark it here A, B, and it is going to reach point 2. When we are going to join these all lines, right, you are going to get a curve or a trace, that is nothing but what? Thermodynamic path. But if you are going in this fashion, that path we can call it as a path A or thermodynamic path A. Suppose if the delivery truck is moving from this point to this point by using this way, that means what? Again it is going to cross series of states or series of places. That when we are going to join these all states, right, we are going to get a curve or a path. That curve or path we can call it as thermodynamic path. If you are going in this way, that path we can call it as a thermodynamic path B. But during this thing here, change of states it is going to happen, dear students. What is change of state? In previous video I have explained in detail. Okay, one example you can take. Okay, one more example you can take it here now, dear students. Now assume that the bus is at this particular point, initial point. It has to move from this point to this point. Assume that point B. It can move from point A here to B. Either it may go in this fashion, either it may go it in this fashion, either it may go it in this fashion. What will happen now? It is going to cross the series of states in all paths or all process, that is known to be what? Whatever path that may be. That path we can call it as thermodynamic path. That path you can call it as a path 1, path 2, path 3, like that you can call, dear students. Now what actually happening there? The properties of the thermodynamic systems, they are going to happen when the system moved from starting point to final point or starting point to final point. What are the properties they are going to change? The properties which are going to change, that property you can call it state thermodynamic property. What is state thermodynamic property? In upcoming classes, in upcoming sessions I am going to discuss. Okay, fine. This is what? Series of state. Now now to understand this series of state, we can take one more example of what? Piston and cylinder arrangement. Dear students, assume that I will take a piston and cylinder arrangement. Assume that I will take a hot gases inside. Okay, hot gas you can consider. That hot gas is going to exert pressure over the surface of the piston. Hence the piston is going to move from point 1 to point 2. When system is moving from point 1 to point 2, right, suddenly it will not move from point 1 to point 2. Slowly it will move. It will come to point, this point, it will come to next this point, it will come to next this point, it will come to this point. These points I can call it as intermediate point A, B, C, D. When we are going to join these all curves, right, all states, right, then what we are going to get? You are going to get a curve or a trace. That trace is nothing but what? Thermodynamic path. Thermodynamic path means what? A system during a process, it is going to cross or it is going to pass the series of states. That is known to be thermodynamic path. What is state? That also I have already told you. What is state now? State is nothing but any condition of the system at any instant of time you can take. Okay, now so 1 to 2, then this whatever the variation is there, right, now you are moving from 1 to 2, right, you are going to get a curve. That curve or a trace, that is nothing but thermodynamic path. How I can show it in PV diagram now? When the piston moved from point 1 to point 2, right, expansion takes place here now. Because of explosive force exerted by the gas on the piston moved from point 1 to point 2, expansion process has taken, but when it is taking expansion process, right, it is followed a path. That path we can call it as a thermodynamic path. Then how to represent that thermodynamic path in PV diagram, that we can see here now, dear students. Now I will take a PV diagram. That means what? Pressure versus volume. Because when the piston is moving from point 1 to 2, right, the state variables, that is pressure and volume, they are going to change. How they are going to change, that we can see here now. Dear students, when the piston is at point 1, you can mark it here now. You can call it as the initial point for your reference. Initial point, that is 1. Then when it moves, right, slowly I will take it as a point A. Next it will move to point B, you can take. Then it will move to point C. Then it will move to point D. Then it is going to move to point 2. That means what? A final state we can call here now. Okay, when we are going to join these all states, right, or all points, then we are going to get a curve, or a trace. That trace we can call it as a process path, or we can call it as a thermodynamic path. Thermodynamic path. When piston is moving from point 1 to point 2, as I told, that is an expansion process. Then if the piston moved from point 1 to point 2, that means the pressure is going to decrease. You can see it in the PV diagram, dear students. Initially pressure is high. When it reaches final state rate, the pressure is decreased. But when it comes to volume, initially volume is less when the piston is at this particular point, right? Initially volume is less. When it reaches point 2, volume increased. Initially it is less volume, but when piston reaches at point 2, the volume increases, but pressure decreases. That means what? Pressure and volume, they are going to vary when the piston moved from point 1 to 2, or that one, if the piston moved from point 1 to 2 is nothing but what? That is expansion process. But the same, you can take another process, that is what? Compression process. In that compression process, what will happen, that we can see here now. So assume that, dear students, now we can go back. Okay, now assume that piston is moving from point 2 to point 1. It is moving in this fashion. Again, it is going to passes series of states. Then when we are going to join these all series of states, then we are going to get a curve or a trace, that is nothing but what? Path. But here what you are doing now, you are compressing the air here now. When you are compressing air, right, what happens now? Slowly volume is going to decrease, whereas pressure is going to increase. That we can show it on the PV diagram, that how it is, that you can see here now. When the piston moved from, now you are at this particular point, dear students, during compression process, you are moving from 2 to 1. That process we can call it the compression process. Assume that you are here, right? Then you are moving from 2 to 1. That means what? 2 to 1 here now. Then you are going to cross a series of states. A, you can take a B, you can take it a B, you can take it C, and in between you can take a D, and you can take it as a final state here 1. When during, again you can join these all lines. Sorry, whenever you are going to join these all points, right, you are going to get a path or a curve. That path or a curve or a trace, we can call it as a process path, that to compression process path or thermodynamic path, dear students. Now in this case, what actually happens? Volume decreases, whereas pressure increases. That means what? Again, pressure and volumes, they are going to vary in expansion and compression process. Dear students, if you want to define this thermodynamic path, you can take this example and you can explain. Okay, this is about what? Thermodynamic path. Thermodynamic path, what is the path? Series of states through which a system undergoes a process, that is known to be thermodynamic path. Okay, fine. Now when it comes to this path, dear students, you can see here now. So there are some important points we need to consider. Initially, when system is at initial point, that we can mark it as an initial state. Then it is going to reach a final state. When it is going to reach a final state, it is going to cross, or it is going to pass the series of states. That series of states, when it is passes the system, okay, it is going to have a path actually. That path we can call it as a thermodynamic path, dear students. Now when this path we are going to get, right, when it is final state, right, as I told, some variables we are going to get. What are the variables? Those variables we can call this state variables. Now as I told, dear students, when piston moved from point 1 to 2 or 2 to 1, either it may be in expansion process or in compression process, there is a variation of what? Pressure and volume. Like that, not only pressure and volume they are going to vary, but another property is also going to vary. That may be temperature, that may be internal energy also. These properties they are going to vary, right? Those properties we can call it as a state variables. Okay, so these are the state variables. What are state variables? That you can see here now, dear students. When the system, you can take example, okay, when system is at initial point, okay, and it is going to reach a final state, then it is going to pass a series of states, that is known to be thermodynamic path. When it reaches the final state, right, when during final state, right, the properties they are going to change. That properties we can call as the state variables, or we are going to get some variables. That variables we can call as the state variables. That variables may be temperature, that variable may be pressure, that variable may be volume, that variable may be internal energy. What is state variables, dear students? That we can see here now. Thermodynamic state variables are nothing but which will give the specific condition of the thermodynamic system. Okay, fine. Now, these students we can take now. This is what state variables. And when it comes to this thermodynamic path, right, that thermodynamic path will play a vital role in calculating the work done or heat generation. That will play in a very important dear students now. So that again we know work is equal to F into dot product of displacement. Example, I will take distance here now. So if you are moving from this point to this point, what we can get? Your work will be less. If you are moving in this direction, your work will be more. If you are moving in this path, work will be more. If you are moving in this path, not only work, heat also more. Hence, this work done and heat generation are path dependent. Path dependent, dear students. What is path function and what is point function, that I can discuss in upcoming sessions. Okay, fine. Now what is this now? So system initial condition, it is going to have a path, then it is going to, when it reaches there, the variables they are going to change. That variables we can call it as a state variables. And when it comes to a path, right, there are two important terms will come, work and heat energy. They depends upon the path actually. Okay, then it is, this is about what? Thermodynamic path. Okay, now when it comes to this thermodynamic path, we are going to have two important types now, reversible and irreversible path. Okay, what is reversible path? Dear students, again this concept I am going to discuss in upcoming classes in detail. Okay, fine. Now reversible path, assume that, dear students, this is a system, you can call it as a system. Okay, the system is moving from one point to another point. Again it will come back to its original position, but there is no any changes in the environment or surrounding. Bus is moving from point A to B. Again it will go from B to A, but there is no any changes occurs in the surrounding. If there is no any changes occurs in the surrounding, if it is following such kind of path, that path we can call it as a reversible path. That means a system can return to its original position and it is not at all causing any net changes on the surroundings or environment. That type of path we can call it as a reversible path. A system can return to its original position without causing any effect or any changes on the surroundings. That is known to be a reversible path. Then how that reversible path is going to happen? That means it will move slowly. Okay, infinitesimal slow. That means what? Slowly that system will move, and it is going to attain thermodynamic equilibrium at each point. You can take it now point 1, you can take it as a point 2, you can take it as a point 3. That means what? It is going to attain same temperature or thermodynamic condition or thermodynamic equilibrium at all states or all point. One thing. And what actually this path, in this path there is no any heat dissipation. There is no any heat dissipation in the surrounding. One thing. And that system, once it reaches final position, right, again it will come back to its original position, but there is no any changes on the surrounding. That type of path we can call it as a reversible path. If this is a path, in this path if the system returns to its original position, there is no any changes in the surrounding. That is known to be reversible path actually. Okay, then that means what? As I told, it can reverse or it can come back to its original position, but there is no any any changes on the surrounding. But dear students, this path we can only imagine or we can think, but we can imagine, but it is not practically possible. It is an ideal path actually. Reversible path is an ideal path actually. Now second one is irreversible path, dear students. Now the system is moving from one point to another point and it is going to go back to its original position, but there is some changes it is going to happen on the surrounding. That path we can call it as a irreversible path. Irreversible path is a path in which when the system going to returns to its original position, but there is some changes they are going to happen on the surrounding. That is known to be irreversible path. How that changes they are going to happen now? When the system, you can call it as a system, when it will come to this point, okay, you can call it as a point 1 and you can call it as point 2. Okay, when it is moved from point 1 to 2, again it will move from 2 to 1. When it is moving from 2 to 1, right, there will be a lot of friction. If there is a lot of friction, then what happens now? Some amount of heat is going to liberate to the surrounding. Hence, the heat is transferred to the surrounding. One thing. Okay, and also some chemical reactions they are going to change because it is going to emit the exhaust emissions, right? That exhaust emissions they are going to interact with the air which is there in the environment. Hence, it is going to cause some changes in the environment when system passing through a path. That path we can call it as a irreversible path. That means what? The system cannot return to its original position as it is in the previous. Definitely there are some changes they are going to cause on the environment. That path we can call it as a irreversible path, dear students. Okay, so again in upcoming classes also we are going to discuss reversible path and irreversible path, dear students. Now to understand what is path, what are the different types of path, I have taken these examples and I have explained you. Again in detail I will explain you what is the reversible and irreversible path in upcoming classes by taking some live examples. Dear students, I hope you understood my lecture. If you really understood, please like my channel, subscribe and share my videos to your friends also. So your small help may give energy for me to do more and more video. Thank you.